Hi everybody, this is Mr. Packard. This is our last 3 weeks of chemistry. We're looking at topics 5 and 6 vocabulary. We're going to learn 2 words today, and then I'm going to get you started on your assignment. We are looking at a word called subscript. It is the number that is below and to the right of an element. It tells you how many atoms of the element in front of that number are present. So for example, if you're looking at carbon dioxide, which is CO2, carbon, it has nothing after it, so it's understood to be a 1, so that's 1 atom of carbon. And the 2 after the oxygen means there's 2 atoms of oxygen. So the 2 corresponds only to the oxygen, and the understood 1 is with the carbon. H2O, which is water, the 2 belongs to the chemical symbol in front of it, which is hydrogen. So there's 2 atoms of hydrogen. And then O, there's nothing after it, so it's understood to be 1. So that's 1 atom of oxygen. The next word is coefficient. It's the large number that's in front of the molecule or the compound. It tells you how many molecules are present. So in the example of NH3, it's understood that there's a big number 1 in front of NH3. That means there's 1 molecule of NH3. NH3 is ammonia, which is a cleaner. NH3, so there is not a subscript after the N, but it's understood to be 1. So there's 1 atom of nitrogen. There's a 3 after the hydrogen. That means there's 3 atoms of hydrogen. So if the molecule does not have a coefficient, a big number in front, then it's understood that it's just a 1. 2NH3 means that there are 2 molecules of ammonia. And you can do this a couple of different ways. Probably the easiest way would be to use the distributive property, which basically means you take the 2 and you multiply it by the understood 1 here, which means you have 2 atoms of nitrogen, and you take the big coefficient 2 and multiply it by the subscript, which is the 3, which means you have 6 atoms of hydrogen. If you're not comfortable with that, you can also write NH3 2 times and add it together. So NH3 plus NH3, and then you count how many atoms of nitrogen there are, which are 2 atoms of nitrogen, or 3 plus 3 atoms of hydrogen, which would be 6 atoms of hydrogen. Again, if the molecule does not have a coefficient, then the coefficient is understood to be 1. Let's take a look at your assignment. And your assignment looks like this. It has the information at the top so that you can be looking at it. We're going to do this on paper. So how many atoms of each element are there? And what we are doing is we are looking at what are called chemical formulas. So CO2 and H2O, those are examples of what we call chemical formulas. And what we are doing is learning how to count how many atoms. And what we're going to do is we're going to utilize that later in the week, and it's going to become really important. And if we can't master this, then it's going to be really, really hard to do what we are going to be doing later in the week. So I'm going to start with number 1. This is Cl2. And so what you're going to be doing is writing down how many atoms of chlorine there are. So the 2 is the subscript that goes with Cl2 with chlorine. And so all I'm going to do is write down that there are 2 atoms of chlorine. NH3, there is nothing after the N, which means it's understood to be a 1. So that means that there is 1 atom of nitrogen, and there's a 3 after the H. So that means there are 3 atoms of hydrogen. And so that's my answer. The next one is what we call, with number 5, it has to do with coefficients. So the easiest way to do this to me is to use the distributive property, is to put parentheses around it. Always put parentheses, and I still use them. I understood that after the N is a 1, and you multiply the coefficient 2 times 1 and then 2 times 3. So 2 times 1 gives you 2 atoms of nitrogen, and 2 times 3 gives you 6 atoms of hydrogen. The other way to do it, if you don't like the distributive property, is to add those two molecules together. So that would give you 2 atoms of nitrogen, and that would be 6 atoms of hydrogen. Either way will get you the same answer. So number 7, 3H2SO4. So I'm going to put parentheses around it, and then I'm going to multiply coefficient times subscripts. So hydrogen has a 2 after it, sulfur has a 1, and oxygen has a 4. So 3 times 2 gives us 6 atoms of hydrogen. 3 times 1 gives us 3 atoms of sulfur, and 3 times 4 gives us 12 atoms of oxygen. Now, if you want to, you can do H2SO4, H2SO4, and H2SO4, and add those together, which would again give you 2 plus 2 plus 2, which would give you 6. Sulfur, 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 which would give you 3, and then 4, 4, and 4, which would give you 12 atoms of oxygen. In this one, I put this one in because you have nitrogen in 2 different locations. All you do is add them up together. They have an understood 1 after them, and there's an understood 1 coefficient in front. So that's 1 nitrogen, you just add them together, so that is 2. There's 4 hydrogen, and there are 3 oxygen. So these are kind of challenge problems, number 21, 22, and 23. So what we do is we take carbon, and there is an understood 1 right there. There's an understood 1 as a coefficient. So calcium just has 1 atom. Now inside of those parentheses, you have an oxygen that's 1, you have a hydrogen that is 1, but we also have a 2, which means there are 2 OHs. So you could do 2 times 1, 2 times 1, which would give you 2 atoms of oxygen, 2 atoms of hydrogen, or you could do OH, OH, atom together, which would give you 2 atoms of oxygen, 2 atoms of hydrogen, whichever you're most comfortable with. Now, this next one, you are going in the opposite direction. So you are taking it from words and you're writing down the chemical formula. We've been taking the chemical formula and putting it into words. So this tells me that there are 4 molecules. That's the coefficient. So I put a big 4 because that's the coefficient. And you have 4 of these molecules right here. And so it says there are 6 atoms of carbon. So I'm going to put a capital C, and that means it's 6. There's 12 atoms of hydrogen, H12, and then we have 6 atoms of oxygen, O, and 6. So this is C6H12O6 is actually glucose, which is absolutely essential. For us, it's also what plants make when they do photosynthesis. So this means there are 4 molecules of glucose. So this gives you at least one example from each of the different types on this worksheet. Don't forget to do the bottom part, which is to put down characteristics of metals, nonmetals, and metalloids.